Hey everybody, welcome back. This is part 2 of our masterclass on HVAC design with Alex Meany, who I go to train with when I want to get better at HVAC design. So we're going to go ahead and dive in where we left off from the last one.
So I don't know if you want to get into the rules of sizing, but that's where Manual S lives.
Yeah, let's do a brief. So if we got, let's just say somebody who wants a Manual J and they've seen Mitsubishi on my channel, they've heard somebody else talk about whatever. So if they have a product line, it's like, oh, I like the top tier of this brand.
This family, yeah. So just for the record, I like Trane, I like Carrier, I like Goodman. I'm brand agnostic, right? I'm actually someone who believes that show me a brand with a couple of exceptions I won't mention. Show me a brand, I'll tell you something they're really good at and probably something they're not so great at, right? Because this engineering is about trade-offs, right? So nobody's good at everything, if you include the idea of making it affordable as some of everything. So I can do everything. It's just going to cost me a small fortune. So when I look up these performance numbers, I should at this point have a load, right? And I now know what the performance of the system is. The reason for that tonnage number, by the way, is for a lot of manufacturers, you have to pick a condenser, a coil, and a blower, if it's not a fan coil, to know what the performance is. So I got to have a place to start. So when it says 2.1 ton, it's not wrong. It's not bad. It's not evil. It's a good place to start, but it doesn't mean go 2.5 because it went over 2. That's not what it means. It means let's start looking at 2 tons, right? So I look at a 2-ton unit. I see what the performance is. Okay. Now I'm going to compare it to what the building needs. I know what it does compared to what it needs. So there's 3 rules. I can get a little trouble for this, but I'm going to do it. I rank them. Okay. There's rule 1, rule 2, which are you don't break these rules. And there's rule 3, which sometimes you have to break. It kind of sucks, but it's true. So rule number 1, you have to have enough latent, right? We just established the load calculation isn't even the most humid day of the year, right? If your system doesn't have enough moisture removal on a day where the air conditioner should be running all day, you're losing ground to humidity. It's getting more humid in your house with the air conditioner running at all times. Nope, that's no good. So you have to have enough latent. Then you have to make sure you don't have too much sensible. It sort of goes without saying that you want to have enough sensible, but it's actually okay to have be a little short, right? If you are a couple of percentage points short on sensible, you know what happens? Your air conditioner runs longer, and eventually the moisture is gone, and eventually you have that energy to spend on temperature control. It's going to work. It's going to be fine. How low would you go? Manual S says you can go 10%. I don't love being all the way down that low, but if I have to, I will, right? If the alternative is that or oversized, I will. So the bigger portion or the bigger question with sensible is not having too much, okay? Because once you satisfy sensible, so we know that you've probably established this in your channel a couple of times. Latent is moisture, sensible is temperature. Good way to remember that, by the way. Sensible makes sense, right? You add heat, temperature goes up. That makes sense, right? You add moisture, you've added energy to the air and you can't see it. It's hidden, latent, it's hiding. Right? That's how you remember those. So you got your latent, which is your moisture removal, and you got your sensible, which is your temperature control. And if you satisfy the temperature control part of it, hey guys, the magic box on the wall, you know what that senses? Temperature. I know some of them sense humidity, but a lot of them don't know what to do if you've satisfied the temperature, right? And even the ones that have some special modes, oh, that's great. I'm sure that sounded awesome. And even the ones that have the special modes, when you satisfy the thermostat and maybe go a couple of degrees past it because they'll let it get a little cooler, it's got to stop, right? It's got to quit. It can't just keep running to get rid of the moisture removal, right? And so what is the latent capacity of a piece of equipment that isn't running? Yeah, 0, right? And so you don't want to have too much sensible because you could have all the latent in the world. If you have too much sensible capacity, it doesn't run. Right? And so when the system isn't running, you have no latent capacity. You have to get that sensible in close. Okay. So how much is too much? So the current code standard, this is pretty simple. The next standard coming out, I actually helped some of the revisions they made to the next Manual S. It's going to be a little more complicated for things like Mitsubishi. For variable speed heat pumps, they're going to have slightly different rules because the capacity of these things is sort of up and down the ladder. But the rule is for single stage equipment, 15%. Don't be more than 15%. If you can get it closer, you should, but don't be more than 15% over. Okay. For 2-stage units, it's 20%. And for variable capacity units, not variable speed fans, it's not about the indoor, it's about the outdoor. But a variable capacity unit you can oversize by up to 30%, according to Manual S. You get into Energy Star, they'll let you have twice as much. Yeah, you have to have a good reason.
Twice as much as 30% over?
Yep. So the rule system works, recommended 15, 20, 30%.
Can I ask a rude question? And I apologize to anyone who's employed at Energy Star. Is this one of those things that somebody just made up who was 23 years old?
No,
and put into
no.
Okay.
They put a decent amount of thought. So people give Energy Star a lot of flack. Energy Star's been through a lot of revisions. There was a time where Energy Star was actually really hard to get. You know what that did? Taught the marketplace how to cheat, right? You can't really meet these on some houses. Yeah, well, we'll meet them. We'll just pencil whip it into submission, right? So you make the goals achievable and you get better results because you don't teach people how to cheat, right? And so we have a problem with Manual S, right? It's hopefully one of the things that the new revision is going to help. We have a limit on how much we can oversize. The sensible limit also applies to total, okay? That, by the way, is my rule number 3. It is a distant third. It has to be a distant third. Why? Because it can be physically impossible to meet that. The difference between 1.5 tons and 2 tons, 33%. Now, if I'm only allowed to oversize by 15%, that's going to be a problem down there at the low tonnages. When they wrote the rule book, 1.5 ton units were weird. 1.5 ton units were like a thing that we didn't have. Like, who has a 1.5 ton? What do they live in a shed? Right? Because we didn't have super efficient buildings, right? We used to live in a 3 ton world. We live in a 1.5 to 2 ton world now, and this rule book is a little constrictive. Now, to be fair, I have more control over the capacity than just what a 1.5 ton or a 2 ton is. We just learned there's no such thing as a ton. So if I control my airflow, if I reduce my airflow, I can reduce my capacity. If I increase my airflow, I can increase capacity. It changes the sensible latent ratios. If I change the way I match up coils, I can have an impact on this. So it's not like there's 18,000 and 24,000, but there is a pretty big gulf, and it is possible to fall in a hole where you can't comply with all 3 rules. So that means I got to pick a winner here, right? And for me, the winner is going to be sensible and latent, right? Total, I still don't want to be oversized on total. I'm not trying to break this rule, right? The reason for rule number 1 and rule number 2 is humidity control. The reason for rule number 3, there's still really good reasons, right? If the air conditioner isn't running much, even if you've satisfied humidity, even if you've satisfied temperature, if the air conditioner isn't running much, it's not mixing the air very well. That means temperature swing issues. Now that can happen year round, but it's not that big a deal in the wintertime. It's not that big a deal for 2 reasons. Number 1, because the sun is actually doing you favors. The sun is not the major source of load like it is in the summertime, right? The biggest part of your load calculation is influenced by the sun. And I don't know if you noticed, but it moves in the sky, right? And so different parts of your house are going to be hot at different parts of the day. So the more air mixing I can do, the better. In the wintertime, even if we said, Alex, the sun's up in the wintertime too, which is definitely true, you can run the fan in the wintertime. You can just turn the fan on, everything's fine. If you turn the fan on constant run in the summertime, you're re-evaporating water off the coil into the air. You are short-circuiting your ability to control the moisture when you do that.
And that's actually a thing that I wanted to bring up too. So I'm glad you got there, because I am actually recommending, because I've got a lot of clients who are coming to me for healthy homes.
Mm-hmm. Oh, you want air changes, don't you?
Running. I want those air cleanings going through that filter. That's a nice 4-inch pleated, huge, oversized MERV 13. And so I am going to be re-evaporating that. And that is not in any of the manuals, right?
Well, it is. They talk. So there is the normative section of the manuals, which is the rule book. Then there's the informative section, right? Normative section is usually a much smaller part of the book, right? You get a book that's this thick. This is the rule book. Shoot, you can condense the rule book for the current Manual S onto like 1 page, right? They managed to really spread it out, turn it into about 30, 40 pages. But the book's 180 pages long or something like that. The rest of it is all advice. It's all best practices. And that is absolutely in there. And so this is probably a conversation we should have when the cameras aren't rolling, because I am of the opinion that, we can have dedicated dehumidifiers. Why don't we have dedicated filters? Right? Why don't I have something that just moves the airflow through that thing?
Yeah. All my clients who want whole house ductless mini splits just got really happy. Now we can go back to this conversation about having an air handler that just does.
You know what I have in my house? I have one of those ugly little monsters, with the 4-inch filters and a box fan sitting on top of it, and it works wonderfully. But everybody hates them because they look ugly and they're kind of loud.
Sorry, Neil.
Yeah, the Comparetto cube. I wasn't sure if this overlapped, right? I always try to call it the Comparetto cube, but I didn't know if the viewers would have any idea what that was. So when we are sizing a system, we can still oversize it even if we meet our sensible and our latent, right? Or don't exceed our sensible and meet our latent. So we really try not to oversize. But if we've got to, that's the one we do. Now, that means we have a rule book that occasionally needs breaking, right? And even if we didn't right now have a rule book that occasionally needs breaking, the guys over at Energy Star, I have a lot of respect for them. Dean Gamble and those people are very, very smart. And they're well aware, and I'm putting words in their mouth. They didn't say this. This is Alex Meany here. But they're pretty well aware, I'm guessing, that technology tends to outpace the code books pretty easily, right? And so if you have a piece of technology that would the manufacturers are recommending you do it this way. They made the product, they're recommending this is how you do it, and the rule book hasn't caught up yet. Energy Star has this option of saying, well, hey, I can actually break this rule, but I need to explain myself and I need to show why, and I need to do some paperwork, some documentation. They don't let you just size it to 150%. That's not the rule. You stick to 30%, just like Manual S says. But if you have to break the rule, it is technically allowable. You just have to provide reasoning. Right? I actually love that. I think it's a great idea because we find ourselves in situations where my load is smack in the middle of not smack in the middle. It's just a little bit over 1.5 tons. Far enough over that I think I'm going to have a comfort issue if I go with a 1.5 ton, but 2 tons is technically too large. And what I can do in that situation, what I like to do in that situation is hunt for the thing. This is what I actually had to do in my own house. I live in a 900 square foot house. It was a one in Boston, right? It's a very low load. It's around a ton. Right? So I ended up putting a 1.5 ton system in there. I couldn't quite meet the rules, but what I did is I found the matchup that met the requirements that I had. I wanted a certain SER, ER. There's a rebate program up there called Mass Save. It's awesome. And when I found that, what I found was the one that gave me the highest latent and the lowest sensible. And it was oversized by like 117%, right? It was 17% oversized on total. But on sensible, I was at 14%. On latent, I was like 400%. I mean, not really, but I was way over on latent. And there is a line somewhere in the Manual S currently that they are not going to put in the next book, if I have anything to say about it, that says there's a certain amount of latent that you don't want to go over. And my favorite part about that line is the very next sentence is, but if you do, it's okay. Right. Thanks. In my opinion, there's no such thing as too much latent, right? There's such a thing as too much total. So if I have a whole lot of latent, what's going to happen to my total? Of course, it's going to go up. So that is a technical concept, but it's not like people are complaining about dry skin issues in the summertime unless they live in a desert, right? So when I'm sizing a system, I have to look at the numbers separately. Every time you take sensible and latent, you make it one number, you're doing it wrong, right? You need to treat these numbers as two separate things. And I don't know how much deeper you want to go than that, but
I think I've been compared to a fire hose before, but I feel like I'm not
so
even
much worse.
Yeah, you're so much worse.
So this actually, I'll keep it light on this one. So 15% is the rule for single stage. 2 stages, 20%. Variable capacity is 30%. So I have to use these rules to make this true. But I have a load calculation here. I did it for Atlanta. It's a normal ranch home. I didn't do anything crazy. Did I reverse engineer it to get the results I wanted? Absolutely I did. But I was able to engineer it in such a way where this load, which the estimated tonnage we'll see here says 4.1 ton, okay? The actual load, which I'm much more interested in, is 35,600 BTUs sensible and 4,700 BTUs latent, okay? Now, if I go with a single stage piece of equipment, I can find a unit that just barely has 100% of total capacity. It is exactly 100%, oh, I lied. It's 100% sensible, 99% sensible, 100% total, and 107% latent. If I'm going to put a single stage system in this house, that's the system I want. That's the perfect system right there because it is right on the nose, right? Does not have too much sensible, has plenty of latent, has more latent than I need, and is right on that match on total. That is going to give me all the runtime I want for dehumidification. And if I'm going single stage, which I know a lot of your clients aren't, but if they're going with a single stage unit, you have to be very careful not to upsize it too much because it doesn't run.
Incidentally, by the way, if you watch that video that was on Matt Reisinger's channel with Scott True, I do his manual J's, and in that video, you can see a lot of the affordable ways that he's building high performance, and he picks single stage equipment a lot of the time. So there's nothing really wrong with that as long as you're doing it right.
Yeah, none at all. And so when I go to a 2-stage unit, which means I'm allowed to oversize things just by a little bit more, I'm able to find a three. Oh, actually, I don't think I needed to go to a two-stage. And this thing is 113% of total, 111% of sensible, and 112% of latent. How is that possible? Well, I'll tell you what, I'm using the lowest airflow I can on the 3.5 and a little bit more airflow than usual on the 3-ton. But both of these comply with code, okay? And I love showing this example. I love showing this thing. And by the way, I'll fast forward to the end. I was able to get a 5-ton variable capacity system that was less than 130% oversized. A 3.5, a 4, and a 5-ton all complied with the code for this one home.
And not just complied with code, because sometimes we use that term on this
it's a
channel
D-
as like
or whatever
it
it is. Yeah,
not that great.
yeah.
But you mean like it actually would perform adequately.
And so I would have better moisture performance out of the first single stage unit. I'd have worse moisture performance out of the 3.5. Right. And so if I went with, I'm sorry, not the 3.5, the 4. If I went with the middle, I went with the 4-ton, and I looked at it and I said, hey, that's going to perform. I could stop there. Right. It met all those rules, and I'm really not bending anywhere. Right. I'm not pushing any lines. I'm well within inside the code performance. And then when I go to the variable capacity, that's where I have to go toward pushing the envelope a little bit. And that variable capacity system might do very well at its job. One of the things about the current system is it treats all variable capacity systems like they're magic and great and awesome. And some of them are not actually all that great at moisture removal.
Like ductless mini splits, for example.
Yeah, ductless mini splits can be a problem area, but sometimes it's even the unitary systems, right? To push SEER rating, right? To get that all important. That's the one that drives sales, everybody. So we're going to bring that efficiency level way, way up, right? We're going to push those ratings. We already learned that we kind of game the rating system already with our indoor temperatures. What they will do is they'll run a coil that's a little warmer, and they'll run a little bit more airflow over it, and they'll make a little more surface area. So you get the same amount of cooling out of it, but you don't have to make it as cold by upping the surface area and maybe adjusting airflow. And by doing that, especially because they test it under peak conditions, but if the little thing's got a brain in it, it's algorithmically controlled. And so when it starts to ramp down, it starts to really push this. That's why you have such huge discrepancies between SEER and EER. EER is at like full run capacity. SEER is during these part run times, right? Where they can really take a bite out of the efficiency apple at the sacrifice of the ability to remove moisture, right? That's why most of those mini splits have that little water drop button, right? I don't use the snowflake. I use the water drop, okay? Because that's better for my home device. Not as efficient. You're losing efficiency, right? And maybe if you're in a climate where you experience dry, hot days and some humid days, you would vacillate between that. But people don't think of Massachusetts as being a high humidity climate. But if you're within spitting distance of the ocean, you're a high humidity climate, right? And so I would be running that on the water drop mode all day, every day, right? So when you're talking about system performance, a better thing to do is to see if manufacturers aren't required to publish any of this data, actually, technically. In order to comply with manual S, they are, but there's no federal agency being like, you have to have this data. No, you have to be able to have HRI data, right? And that's it. Now, if you want a decent product, you want people to buy it, you want people to think it's any good, you should probably publish this data. But there are manufacturers out there, we won't name any names, but they sell direct to homeowners that don't have this data, right? I've asked for it like 3 different ways. I've put on disguises, right? Pretended I was a homeowner trying to get a permit from somebody. I tried everything to try to get the data until finally somebody said, yeah, we don't have that. Like, okay, well, all we need is HRI. All right, there you go. There's your D-, right? We complied with the code. But understanding down to a deeper level of detail at what the sensible and latent capacities are, ideally, as the capacity is coming down and it's running at lower stages, that's when you really know you've got a system that's going to work in those circumstances. This load, I put a 5-ton variable capacity system on this. It might work great. It might work terribly. If I look at how it's going to run when I get to 80%, 70%, 60%, and the manufacturers provide me, and they won't give you every one of those data points, but they'll give you a couple of keys from the ones who care and the ones who publish that data. If I can see that it's going to maintain its moisture removal all the way down through that, yeah, it's going to work great.
And if you did not go the extra mile and look at all that stuff, Are you still complying with?
I'm still complying with code, but I
Yes.
might have a serious moisture removal problem because the thing is never going to run at that peak capacity. And as it starts to ramp down, it's losing its ability to remove moisture because they optimized it, as Brian Orr likes to say, they optimized it for SEER, right? Because you can't optimize for SEER and dehumidification. You can do both, but you can only optimize for one.
All
right?
engineering is trade-offs.
So, exactly, right? And so you can be in a balance. You could have something that's awesome at moisture removal. The Daikin Fit has some issues getting rebates, right? Everybody's like, oh, it's variable capacity. I'll get all these rebates. Look at the high SEERs. The EERs are kind of bad, right? Not bad. They're what happened when you design a system to remove moisture. That's what you get. So yeah, everything's trade-offs. And if you look at, if it's the design process is about looking facts in the face and dealing with them, right? Like that's what we're doing here, right? There is no single magic bullet that's going to solve every single problem. We need to identify the problem. We need to look at the solutions and see which ones match, right? And if you've got a big budget, you can usually find something in that variable capacity range that's going to do a wonderful job. But when you start to go like, well, I can't afford this one. This one over here seems pretty cheap. And you don't dive into, I'm not saying it's bad, right? Everything has its place in the marketplace. But if I needed to do something it's not capable of, I'm in trouble. So I need to know what it's capable of, right? Speaking of Brian Orr, right? RTFM, do you use that acronym around here? Read the fantastic, we're not going to say the other word, manual. Yeah. You look it up, right? My thing for 20 years was look it up. I was a look it up guy, right? I heard RTFM and I was like, oh, I should use that instead. It's funnier. Just, you got to look it up. If you don't know, if you don't look it in the face, you don't say, this is what I have. You don't look at reality and go, this is what's going to happen. Then you're guessing.
And that's essentially what the whole HVAC design process is about. And by the way, you just saw the difference between a free manual J that somebody just does as a process of the install that they're going to do on your house and what is possible to really have somebody do, which he's, like he said, he's not going to be doing a lot of manual Js for individual people because probably he's incredibly expensive. I tend to be pretty expensive as well. And he doesn't teach people to do exactly what he's doing. If you want to study with him, he will teach you a way to practically do it so you're not breaking the bank on every single job because like you can't do what he's describing on every single house because your brain would explode.
Well, you can. You can. Because when you start to look at data, you can start to see trends. You can start to identify. So you know what your average contractor does who isn't doing this stuff? They're doing good work by when they get burned, they don't use that thing anymore. Right? I put in 3 of them. They all sucked. Guess what? That thing sucks. If you looked at the data, you would have seen that it sucked. And what you would have seen is it sucks at this and it's okay at this and it's all right and it's better at this. And if that's what you need, it's still an okay product. But when it randomly fails on you, you identify it as bad. And so what a lot of people end up doing is those middle balance things, right? This is where they like to live because it burns them a lot less. But if you're looking at the numbers, those trends still emerge. Right? I don't have to look up 9 different systems to see which one's going to work. I look at the load numbers and I've looked them up 3 different times this week. I have a pretty good idea of what it's going to be. And for the record, there's contractors and there's contractors and there's contractors, right? I just spent the last 2 days dumping this brain into them for 18 hours so that they could do a better job at this, right? And they're going to be able to go to my website and for, if you take the class, right, you pay the $500 for the class, you get for 60 days access to every one of these lessons that I already have pre-recorded in a video, right? Which, by the way, if I'm not coming to your town, go ahead and sign up for that. You can just listen to me do it on a video. And if I'm going too slow for you, hit fast forward. And if I go too fast, hit rewind.
I don't think you go too slow. That's probably not the problem.
Sometimes for some people.
But the issue here with you have to find a middle ground. You can't do the free thing or the guessing because that guy who guesses. People nowadays are asking for very specific things from their homes, whether it's the healthy thing with the filtration or whether it's I want my house to be super insulated and I want whole home mini splits everywhere.
Yeah.
Or I want it to be this or I want it to do that or I want all glass or no glass or whatever it is. So it's like choosing that middle ground. There's no houses are going off the map.
Yeah.
In my experience.
Yeah.
So one last question. Because we're not going to get into manual D because I've got this list of questions
My
here.
bad.
I'm scratching one. It's fine. But manual T, we talked about this. So manual T is about selecting the terminations of your ducts, so the grills and the registers and stuff like that. And do people actually read this and do it? Is my first question.
I mean, Ed Jonawak over at ACCA is on a mission to get as many people to read and do this as humanly possible. But here's what very few people, I think, I don't know, right? I'm not in everybody's business, right? But very few people are probably reading and following the manual T. Fun fact though, if they have a catalog from their register manufacturers, yeah, most of them actually have a little condensed version of the advice you will find in the manual T, right? It's about sizing the grill and about getting the velocity right so that you get proper throw and you get proper spread and you get proper coverage. And the catalog is where it tells you what it will do. And again, you'll look it up, you determine performance, and you match it to what the needs are. The problem is what the experts call LLH, right? Low load homes. The more efficient the thing is and the bigger it gets, the fewer CFM I'm trying to move for every square foot in here, right? If I have a super efficient space and I have this big space and I have this one little itty bitty register and it only needs to be 80 CFM in this giant space. 20 years ago, this thing would have been 300 CFM and now I need 80. Oh my goodness, how am I supposed to get all the air to circulate there? And so luckily, the air circulation need is not quite as high as it used to be. Believe it or not, I will skip this particular conversation, but ask me about mean radiant temperature sometimes.
We'll do that when we build our mean radiant temperature thermometer.
Oh, cool.
Soon. So,
very cool. Okay, so radiant heat is a lot to do with comfort. And when you have crappy construction, your exterior surfaces are all cold or hot, depending on what the season is. So we better get the air there and warm them up a little bit so that I can be near them and be comfortable. Well, if I have R1,000,000 in my walls, that's not going to be a problem, right? All I need to do is make sure the air is somewhat moving in the space. And there is a thing, it's a magic word. It's called entrainment, okay? Entrainment is, I don't know how this is going to go on the microphone, so we'll see. But the easiest way you can test entrainment is take 2 fingers, put them on either side of your mouth like this, okay? Just right here, right? And go, just breathe out. You won't feel anything because they're on either side of your mouth, right? And then, and you'll feel air moving because the higher velocity air creates a low pressure on either side, which pulls the air from here along with it, right? So you have to achieve a certain velocity so that you're not just throwing the air and seeing where it goes. You want a force multiplier. You want something that's going to pull the air from what's around it, right? Now, that'll only get you so far. 80 CFM in a giant space still might not get you there. But if you get that velocity, you can get a lot more air mixture than you think. So your number one priority is that velocity. But you know what happens when the air moves real fast? It starts to get loud, right? And so if I was going to go with ideally, this is what I would have if I was going to cover the air, blah, 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 you're going to be dealing with velocities that would sound like a jet engine, right? And the thing that we talked about when we talked about this earlier was I'm not entirely sure that ceiling fans shouldn't just be under the HVAC umbrella at this point, right? And if you have literally, how the heck, the math stopped working years ago, right? The physics something's got to give. I got a giant space. I got a little airflow going in it. I could have stagnation problems with airflow, right? I can do a lot with entrainment, but it's not magic, right? It's only going to do so much. And so now you got to start thinking outside the box for moving air. And it ain't exactly rocket science. What moves air? How about fans, right?
And the ceiling fans that we have in this house that we just designed to kind of run all the time on low speed, they're probably pulling about 20 watts or something like that when they're just sitting like that. And they're moving a ton of air around. You can't feel it. That's important.
Yeah, you don't want to. You just want that air mix.
Yeah.
That's all we're doing.
So you can tell that there's a lot going on in here. And I'm going to have links to the things that Alex has mentioned below. There's more to learn from his site, meanhvac.com. And you're going to see him back on this channel more. Make sure that you guys if you have questions, put them below. I'm going to try and drag him over to the comment section and ask him to address some of those if they're
I'll shoot
specifically for him.
Yeah, absolutely.
And then also feel free to comment. Please do like and subscribe. Tune in next time.